a dinosaur died sitting over a nest of at least 24 eggs. 7 still contained the bones of unborn young. Did it know these were its own? For years, dinosaurs like this were associated with egg stealing. But this adult was not attacking the clutch. It had settled directly over eggs containing embryos of the same kind of dinosaur. Some probably did in a practical sense, but not in the human way the word family makes us imagine. Most documentaries treat this as a simple story. Good parent, guarded nest, case closed. The fossil record is messier than that and more interesting. Nest attendance is clear in some dinosaurs. Post-hatching care is strongly suggested in others. Recognizing the correct nest, familiar calls, or dependent young is plausible. The first clue is the exact position in which this adult died. To test recognition, we need 3 questions. Could a dinosaur find the correct nest? Could it distinguish familiar individuals or young? And did it understand family as humans do? Fossils can approach the first 2. The third remains beyond what bones and eggs can reveal. The adult was an Oviraptorid, a feathered beaked dinosaur with a strongly bird-like body plan. Its skeleton lay above a circular clutch. Its limbs were spread around the eggs in a posture often compared with a brooding bird. That position matters. The animal was not simply fossilized somewhere near a nest. The adult, the clutch, and the embryos formed one direct association. This was not an egg thief caught in the act. The adult belonged with the nest. And the fossil carried a second surprise. The 7 embryos were not all at the same stage of development. That suggests the eggs may have hatched at different times. If the adult remained, the nest would have changed from unhatched eggs to a mixture of eggs and active young. At minimum, the fossil supports prolonged nest attendance. It is also consistent with brooding, guarding, or protecting the clutch. Recognition is harder to demonstrate. An animal can return using smell, landmarks, nest shape, or learned location. It does not need a human-like idea of ownership. Still, an adult investing in one clutch would benefit from finding the correct nest and responding to its changing condition. The fossil cannot reveal the adult's thoughts. It reveals a situation in which recognition could have been useful. As the evidence builds, notice which clues truly require recognition and which could still be explained by instinct. First, was this adult warming the eggs, guarding them, or doing both? Researchers have compared dinosaur nests, egg arrangements, incubation times, and adult postures with those of living animals. Some theropod eggs were arranged in rings, leaving space near the center for the adult's body. That is consistent with brooding. But dinosaur nests were not all alike. Some eggs were partly buried. Heat may have come from sediment, sunlight, the adult, or a combination of sources. The exact method remains debated. The adult may have warmed part of the clutch, guarded it, or helped regulate conditions around the nest. The uncertainty does not erase the strongest fact. This animal remained directly over embryo-bearing eggs. Egg care is strongly supported. Recognition is plausible but not proven. And eggs are only the beginning. Protecting a clutch is one thing. What happened after the shells opened? Maiasaura has been linked with dinosaur parenting for decades. The important question is not simply whether young were found in nests. It is whether those young could survive without adults. A 2025 study estimated the likely metabolism and developmental condition of newborn Maiasaura. The researchers concluded that the hatchlings were most likely dependent, not animals ready to leave the nest and feed alone immediately. Their model suggested intensive care, including feeding and protection, may have been needed for roughly 40 to 75 days. That conclusion applies to Maiasaura. It should not be extended to every hadrosaur or every dinosaur. But 40 to 75 days means repeated contact. Adults may have returned to the same nest, protected the same group, and responded to calls or movement from dependent young. That makes recognition useful, although an adult could still identify the nest by location rather than know every hatchling individually. Even so, parenting may have continued for weeks after hatching. Then another species left a completely different clue. Maiasaura left young inside nests. Lufengosaurus left babies, whose own legs may reveal what an absent parent had to do. Lufengosaurus was a long-necked plant-eating dinosaur from the early Jurassic. Researchers examined its embryos and compared their developing limbs with modern birds that hatch at different levels of independence. Some birds emerge ready to move. Others hatch weak and depend on adults for food. The researchers argued that Lufengosaurus hatchlings were closer to the dependent condition. Their limb bones may not have been strong enough for immediate independent foraging. That made parental feeding a serious possibility. No fossil shows an adult placing food into a hatchling's mouth. The argument comes from bone development, anatomy, biomechanics, and comparison. But that is what makes this clue powerful. The parent is missing. The possible care is inferred from what the baby could not yet do. If the interpretation is correct, caregiving continued after hatching, making recognition useful without proving that every offspring was identified individually. So far, every clue has pointed the same direction, toward care, attendance, and dependence. The next fossil is the first one that could go either way. To search for familiarity beyond nests, we need dinosaurs preserved with companions. 4 juvenile protoceratops were found closely associated and at similar stages of growth. That supports age-based grouping. Young dinosaurs were not always solitary animals, moving through the landscape alone. A group could have offered protection through numbers, shared vigilance, or easier access to the same resources. Repeated group living also creates reasons to recognize familiar companions. But this fossil contains a trap. 4 young dinosaurs do not automatically make 4 siblings. Their parents may not have been nearby. The animals could have gathered because they were similar in size, used the same habitat, or faced the same danger. The fossil supports juvenile association. It does not reveal kinship. That distinction matters because one emotional label can turn real evidence of social contact into a family story, the fossil never preserved. 1 Avimimus Bonebed represents at least 18 individuals. Most were adults or subadults, with very few small juveniles. That strongly suggests these bird-like dinosaurs gathered together. But it is almost the opposite of a parent and baby scene. The researchers could not determine exactly why the group formed. It may have been connected to feeding, safety, movement, or another social behavior. 18 animals, and almost no babies among them. Whatever drew this group together, the bonebed does not resemble a parent and young nursery. Sauropod nesting grounds provide a different kind of association. At one site in Argentina, dinosaurs repeatedly returned to lay eggs in a warm, moist environment that favored incubation. That shows repeated use of the same nesting ground over time. But recognizing a useful location is not the same as recognizing offspring. A colony also does not prove shared childcare. Nearby adults may have cooperated, competed, tolerated one another, or focused only on their own nests. Fossils reveal the setting. They rarely preserve the social rules inside it. Living animals can show what kinds of rules are possible, but they cannot provide a shortcut to certainty. Living birds provide many examples of adults recognizing nests, mates, chicks, calls, and familiar neighbors. Different species use combinations of voice, appearance, smell, location, and repeated contact. Crocodilians also guard nests, respond to hatchling calls, and assist young around hatching. These comparisons show that parental communication and recognition are biologically possible in animals useful for understanding dinosaur behavior. But a behavior in a living bird does not prove that an extinct dinosaur performed it. Dinosaurs included many species with different bodies, environments, and life histories. The correct argument is not that birds do it, so dinosaurs did it. It is this: living animals reveal possible mechanisms. Fossils reveal situations in which those mechanisms would have been useful. And when several independent clues point in the same direction, the case becomes stronger. So what does the full evidence ladder allow us to say? Did dinosaurs recognize their own families? Some probably distinguished familiar individuals. Certain species may have returned to a particular nest, responded to familiar calls, or recognized a regular group of dependent young. The strongest evidence supports prolonged nest attendance, brooding-like behavior, weeks of post-hatching dependence in particular species, and repeated social association. But fossils cannot directly prove that a dinosaur remembered every offspring as an individual, and they cannot establish a human-like understanding of kinship. The honest answer lies between two extremes. Dinosaurs were not simply egg-laying animals that always abandoned their young. But we also cannot turn every nest, colony, or juvenile group into a prehistoric family portrait. The evidence strongly supports care in some species. It makes practical recognition plausible. And it suggests that, for certain dinosaurs, survival depended on repeated relationships lasting well beyond the moment an egg was laid. Here's the real test. Which clue comes closest to supporting recognition? The adult over embryo-filled eggs, or weeks of dependent hatchlings? And which could still be explained without it? Make your evidence-based case in the comments. For more evidence-led dinosaur mysteries, subscribe. And if some dinosaurs recognized familiar individuals, the next question is even bigger. How close did dinosaur intelligence come to flexible, learned behavior? Watch the dinosaurs that came closest to a stone age on screen now.